Alright, so welcome to Logic Online. We're going to try to do this as best as we can. And what we're learning today is natural deduction, which is another technique that's used for testing validity in propositional logic. Actually, the truth table method that you learned the last time was a test for invalidity. This natural deduction is a test for validity. And it uses 18 different rules, but in 7.1 we're only going to look at 4 that you're already familiar with from the last section. These are the modus ponens, modus tollens, disjunctive syllogism, and hypothetical syllogism. Just to remind you, the modus ponens takes the form if square then circle, square therefore circle. Modus tollens, if square then circle, not circle, therefore not square. The disjunctive syllogism, square or circle, not square, therefore circle. And the hypothetical syllogism, if square then circle, circle then triangle, therefore square then triangle. And the idea is to look at an argument and using these techniques, kind of like the sorites that you learned in categorical logic, we're going to prove that an argument is in fact valid. Now, what I'd like to do is kind of show you first of all a basic technique, and then from there we'll kind of go back and work at it a little bit more slowly. So let's take an argument as we're traditionally used to seeing it. So for example, if A then B, not A then C or D, not B, not C, therefore D. Alright, so that's the way we're used to seeing these arguments presented to us. Now what's going to happen in this form of logic in natural deduction is that it's going to be written a little bit differently. You see, each line is going to be numbered. So line 1 would be if A then B. Line 2, not A then C or D. Line 3 would be not B. Line 4, not C. And then the conclusion goes after a slash on that last line. It does not get a line of its own yet. Now here's the idea. You're going to start by looking at the 4 individual lines here and trying to see which 2 match up to the premises of either a modus ponens, modus tollens, disjunctive syllogism, or hypothetical syllogism. So you should notice, for example, that lines 1 and 3 would make a modus tollens. Right? So here's line 1 is if A then B. Line 2 is not B. Right? So if square then circle, not circle. And so what conclusion would you derive through modus tollens? It would be not square. And the square is A. Okay? So remember that with logic, the conclusion that you're drawing here, it's not something new. It's already contained within the premises. The trick is to bring it out, to make it manifest so we can use it. So here on line 5, you're going to put not A, and you're going to show that that comes from 1 and 3, and you want to show how you got it, so that's modus tollens, like that. Now you simply go back and look at it again. Which 2 lines could work together now? Well, lines 2 and 5 would make a modus ponens. Right? So you've got not A, then C or D, not A. So if you think about it, right, your antecedent is the square, your consequent is the circle, so not A is the square. So your modus ponens form, if square then circle, square therefore circle. And the circle is C or D. Okay. So now you've derived that. We'll put it here, C or D. And that comes from 2 and 5 through modus ponens. And now we go back and do it again. We're just going to keep doing this until we reach the conclusion, and that's going to prove it. So right now you can see that lines 4 and 6 would make a disjunctive syllogism. Right? C or D, not C. So C is the square, D is the circle, C is the square. So it's either square or circle. It's not the square, so it has to be the circle, which is D. So here on line 7, we have D, which we got from 4 and 6 through a disjunctive syllogism. Now, because we've reached the conclusion that we were trying to reach, which is D, we have just proven that this argument is valid. And that's the technique that you're going to want to be able to use from this point onward in order to test validity, not only in propositional logic, but also later when we get into predicate logic in Chapter 8. This is called a proof. Now, the nice thing about this text is that all the things that you're dealing with are in fact going to be valid. So it's not really going to be a question of proving whether they're valid or invalid. They're all valid. It's just a matter of being able to demonstrate it. Can you show the different steps? Now, I do a lot of this stuff along the side here to kind of help you, to guide you, and you can do that too if you want to, but in the end, this is all that you really need to be able to show, okay? And so again, just like those sorites, you're finding the premises that match the basic form, deriving the conclusion. That conclusion becomes another premise, which you can then use, and you just keep working at it until you reach that final conclusion there. So that's what you want to ultimately be able to do. Let me erase this here, and then we'll go back and look at some things a little bit more slowly. Actually, the way that the homeworks are set up here really help us a lot. So if you take a look at exercise 7.1, section 1, this is page 396 in my edition. Might be a few pages off in yours, depending upon which one you're using. But in any event, what's happening here is that it's giving you a chance to just help your eye to visualize these different forms. And so we'll look at these particular problems here. And let me just throw a couple of these up on the board here for you. So the first one, we have G then F. And line 2 of that is not F. And line 3 looks like that. So the idea is to see if you can figure out simply which form, modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, that we're dealing with. Now in this case it's very easy because there's only 2 lines, right? Lines 1 and 2, so you know that's what you're going to be using. And then we simply look at what's presented to us in those 2 lines. So here we have a conditional statement, and here we have the negation of that statement. Automatically that should point us to modus tollens, but if you want to do the squares and circles to show it, make sure you can do that. Remember, the antecedent takes the square, the consequent takes the circle. And so here is the circle. So if square, then circle, not circle, therefore, modus tollens, not square. The square is G. And so you would demonstrate that from if G then F, not F, you would derive not G using modus tollens. As you go on with these, they add a few more lines for you. And again, it's just to help you to visualize here. So let's look at number 5. We have in or F. If in, then K. And line 4 is what's missing. Okay. Now, of course, each of our arguments only has 2 premises. So we're going to figure out 2 of these that we can use, and we're just going to throw away the other one for this exercise. Okay. So lines 1 and 2 are not going to work together because you've got N or F. That would be the disjunctive, but the disjunctive syllogism would require a negative, and we don't have a negative, we have a positive. Clearly 2 and 3 are not going to work together because they don't look like any of our 4 basic forms. So that leaves us with lines 1 and 3. Lines 1 and 3 look like they would make a modus ponens, right? And remember, you can use these in any order. So if N, then K, N. So if square, then circle, square, therefore circle, the circle being the K. So you would derive K from lines 1 and 3 using modus ponens. We don't need line 2. Then as you move on with it a little bit further, let's say number 9. Now it just gives you 4 lines instead of 3 or 2, but the idea is still the same. You have to start with what you're presented, figure out which 2 lines are going to work, and get rid of the others. So if F, then not A. N, then A. Not F. Not A. And then line 5 is what we need here. So now I would start by looking at the fact that we have negative premises down here, so I'm thinking of something that's going to fit the modus tollens form. It might help you actually to go ahead and draw that out, at least in the initial stages until you're comfortable with it, like this. So if square, then circle, not circle, therefore not square. Now, we can kind of visualize here that if we use not F in the circle spot, then F would have to be in the consequence of this line. We don't have one where F is in the consequent. So what if we use not A? Well, if we use not A, then A has to be in the consequence, and we have that here on line 2. So there's if N, then A, not A. Right? So if N, then A, not A, therefore not square, the square is N. So line 1 we don't need, line 3 we don't need, but from 2 and 4, using modus tollens, you would be able to derive not N. Okay? So that's basically a technique that you can use, and that's what this first section's exercises are for, is just to help you to visualize, so that these different forms start jumping out at you, so that you'll be able to see them without having to search too intently. So the more you work with them, the more comfortable you're going to be with them. And so that's basically the idea behind this section 1. And so what I have asked you to do in terms of homework, I was working on some of the odds, but I'll let you do 1 through 20 even on that section. And of course I'll put it up on Blackboard as an assignment too, but try 2 through 20 even on 7.1 section 1. And I think that'll give you some practice to where you start becoming familiar with these different forms that we're working with and helping them stand out so you can derive the conclusions. At section 2, it's kind of going to be working along similar lines, except now you're going to be giving a premise and a conclusion, and you have to figure out the premise that's missing. So again, it's going to start fairly simple and straightforward. We'll take the first one there. We've got B or K. Line 2 is missing, and line 3 is K, and they want to know how we derived it. Well, again, with these early ones, it's very easy because there's only 2 lines presented to you, 1 and 2, so you know that the conclusion is going to be derived from lines 1 and 2. We also see that there's a wedge here, so the only thing we could use would be the disjunctive syllogism. That's the only one that uses the wedge. So again, if it helps you, you can draw out the squares and circles. Okay? Square or circle, not square, therefore circle. B is the square, K is the circle, and as we see, K is the circle. So all we have to do is figure out what's missing. Well, it's the negation of the square, which is B. So not B is what's missing in order to derive the conclusion K using disjunctive syllogism. Okay. Now the reason for this is because when you start to use the natural deduction to determine validity, what you're going to have to do is use both of these techniques. The one you're going to use primarily is going to be from the section 1 that we looked at, where you have to figure out from these two premises what conclusion could be derived. But there are some times where it's also going to be useful to try to look at the conclusion that you want to end up with and what you're given and what might be needed in order to make that happen. So that's what this second set of exercises here at 7.1 section 2 on page 397 is supposed to do for you. So let's look at another one of those. How about number 5? So number 5, we have if F then N. We have if N then T. Line 3 is missing. And line 4 is not F. And they want to know how we derive that. So now, just like before, of course, there's only two premises in each of these. So we're going to use line 3 with either line 1 or 2 in order to derive that. Well, when I see the conclusion is a negative, my first thought is of modus tollens. So again, draw your squares and circles here. If square, then circle, not circle, therefore not square. The conclusion we want to reach is not F, so that means the square has to be an F. Well, line 1 has the F as the antecedent, line 2 does not, so we're not going to use line 2. Line 1 is if F, then N, and so the circle is in. So what's missing here to draw that conclusion would be not in, which we get from 1 and 3 through modus tollens. And let's look at one more. How about number 11? Looks like fun. We've got if T then N. G then T. H or T. Line 4 is missing, and line 5, the conclusion we want to reach is if F, then T. Okay. So looking at this one now, obviously, we're going to use line 4 along with either 1, 2, or 3. We're going to use 1, get rid of the other 2, in order to derive the conclusion. The fact that the conclusion is a conditional statement makes us think that it's going to be a hypothetical syllogism. So let's just go ahead and set that up over here. So if square, then circle. If circle, then triangle.